So in chapter 2, you learned how to square root any graph. We just finished doing the reciprocal of any graph. And the last thing we're going to look at is the absolute value of any graph. So these really could have been their own unit. We put the square root in chapter 2, and we're putting the 1 over f of x and absolute value of f of x in chapter 4. But they're very connected to each other. Okay? Right? In the nice points idea, all that happened is your y value on your original graph, you just square rooted it and got your y value on your new graph. Here, your nice point, all you would do is take your y value and you did 1 over y, and that got your nice point. And same thing here, all we're going to do is take our y value and do the absolute value of it. And graphically, that's fairly straightforward and easy to do. Okay? So, does it make sense if absolute values are always positive? If you have the absolute value of a function, the entire graph will be up and above y equals 0, because all of your y values will be positive. So, given f of x equals 2x plus 3, we want to graph the absolute value of f of x. So just like we did in square root graphs and reciprocal graphs, the process is the same. We're going to graph y equals 2x plus 3 first. So I have a y-intercept at 3, a slope of 2 down 2 over 1. I'm going to label my y-intercept. I'm also going to label my x-intercept. Maybe I'll put that in here. Label x-intercepts. So how do you find an x-intercept? You can make y equal to 0. And if I made y equal to 0, my x-coordinate would be negative 1.5 or negative 3 over 2. And now we do nice points, just like before. One of those nice points is going to be your x-intercept. That's going to be the most important point, and it's going to stay the same, because if you absolute value 0, it's going to stay the same to be 0. What happens if I absolute value my y-intercept here? I have 0, 3. Can you see that that would still be 0, 3? Can you see that this whole section where the y values already were positive is going to stay exactly the same? But if I would take a point, say over here, I don't know, maybe I'll use negative 3, negative 3, because that would be on my original graph. Negative 3, negative 3 would change to negative 3, positive 3. And the easy thing about absolute value graphs is because everything that's negative becomes positive, how do you make something negative become positive mathematically? You would need to multiply it by a negative. And we think back to chapter 3 in transformation. When you multiplied your y values by a negative, that was a vertical reflection. So the whole part that was negative is just going to get vertically reflected up and become positive. And this is our new graph. So the idea for absolute value graphs is you're going to graph your original function. You're going to label your x-intercept because that's going to be a key place where things switch. Then wherever your graph was positive, it stays positive. Absolute value does nothing to positive y values. It stays the same. But wherever your graph had negative y values, you're going to reflect it up over the x-axis because you need to multiply it by a negative. So absolute value graphs say graph your original and flip up what you had from before. Now, this question we could have also have done using transformations, because in transformations, this was one of your parent graphs. The V graph was absolute value, right? And you would recognize, hey, this is an absolute value graph with a horizontal compression and a horizontal translation. But if I use transformations, this would actually be a little bit more complicated. Because do you remember that when you have a horizontal compression and translation, it has to be in factored form. So you have to factor out the 2, giving you x plus 3 over 2. What would this do? Horizontal compression by a half. And then shifted 3 over 2 to the left. You see that we have the shift of 3 over 2 to the left? You'd have to do a little bit of work to do the compression. I think the new method's actually easier. The new method of graph the inside and just flip what's underneath above, I would probably actually recommend this all the time as an easier method than our old method. You don't have to do factored form. You don't have to do like each point, where is it going to go? We still need to know how to do that, but in this situation, I now think that the new method is better. And we can even do, and have another example here, we can even take a graph from chapter 1. So if you had f of x is x times x plus 3 times x minus 2. You recognize that this is an x cubed graph. Its end behavior, because it's positive, acts like a line. So we know it would have that. It's in factored form, so you would know that at minus 3, 0, and 2 is where your x-intercepts are. And if your end behavior said start down here, end up here, each of our x-intercepts has a multiplicity of 1, so it goes straight through every time. So first, you have to graph f of x first. That's a graph from chapter 1. We have to remember how our x-intercepts work, how our end behavior works. Then the steps for the absolute value says, whenever your y values were positive, they're going to stay positive. Because if you absolute value a positive number, it stays positive. Then wherever things are negative, so it looks like I have like 1 comma negative 4 about, that would become 1 comma positive 4. And this part that was negative would get reflected up. And this part of the graph that was negative would get reflected up. So all an absolute value graph does is reflects the negative part of the graph up. Draw your original graph, label your x-intercepts because that's where things change. Wherever your original graph was positive, it's going to stay the same. But if your original graph had negative y values, absolute value makes them positive. And making negative values positive is like multiplying by a negative, and multiplying your y values by a negative is a vertical reflection from chapter 3. It just flips it up. And because absolute values are not hard, I have seen sometimes on the exam, they add an absolute value and a transformation together. Just a simple one, but to try to see if you can combine both of those ideas together. So in this example, let f of x equal square root of x minus 2, and we are going to graph y equals the absolute value of f of x minus 3. So first of all, if you got something new like this on the exam, ask yourself if you have the skills to solve this. And you're going to have to do some problem solving here. If the minus 3 wasn't here, could you graph the absolute value? Yes, all that would do is flip part of it up. If this was just g of x, just something, what would the minus 3 do to your graph? It would take whatever graph you had, a minus 3 just moves it down 3. So what I'm going to do is I'm going to graph the f of x1 with the absolute values first, and then whatever graph I have to move it down 3. So as far as, well, how do I graph the absolute value? My very first step is I'm going to graph y equals f of x first. So what does that look like? It is my square root graph moved down 2 units. If I think about my square root graph, it usually has 0, 0. Now it would have 0, negative 2. Then it would have 1, negative 1. And important to label my x-intercept. There's my square root graph moved down 2 units. Switching colors. I could graph the absolute value. Well, what would the absolute value do? The absolute value would take these nice points and make them positive. So I would have now 0, positive 2, 1, 1. I still have 4, 0. The part that was positive, this part right here, would stay positive. But this part would have got reflected up. So my negative part would have got reflected up, and my positive part would have stayed the same. And finally, change to purple, I can now graph y equals the absolute value of f of x minus 3, because that would just be my green graph shifted down 3 units. So what would that look like? Well, 0, 2, if I shifted that down 3 units, would be a 0, minus 1. If I took 1, 1 and shifted it down 3 units, it'd be at 1, negative 2. And if I took 4, 0 and shifted it down 3 units, it would be at 4, negative 3. Okay? What's an interesting thing about this question, absolute values, if you just have the absolute value, does it make sense that nothing for your y values would be negative? But if you subtracted 3 afterwards, now you allow some of it to be negative. Does that make sense that some of it could be negative now? Because we've shifted it down 3. Okay? I know that some of the students, when they see these combined, they get stuck in their mind that, oh, I see an absolute value, so it all has to be positive. Well, this part, the green graph, all had to be positive. But when I shifted it down 3, now it's possible that some of it could be negative. So if they do combine transformations that way, just think about, well, what could happen here? Absolute value by itself is always positive, but if you do something after, it could change. So if you combine, and I guess this is possible, they could do this with any one of these 3 special ones. So we'll call these special transformations: square rooting any graph, reciprocating any graph, absolute valuing any graph. Those are special ones. And they could add a transformation to the special ones. If they do that, what did we do? We graphed the special one first. We graphed 1 over in green. We graphed that first, and then we did the transformation afterwards. You get stuck on these, again, anytime you're stuck on a graphing question, go back to the most basic idea of graphing. You can always do a table of values to check your points. Right? If you got lots of time on your exam, you could check thousands of points. It would be a really waste of time, but you could. Just check point after point after point after point and get a whole. If you had 1,000 points on a graph, it would probably be a fairly accurate graph. So don't forget tables of values for graphing questions when you're stuck on something, or if you just want to confirm that you've done something right, because that can be very, very helpful.